Hello. In this video, I'm going to explain problem 3 from the 2014 F equals ma contest. We are told that an object of uniform density floats so that 20% of the object is above the water, meaning that 80% is below, and then a 3 Newton force presses down on the top of the object so the object becomes fully submerged, and we're asked to find the volume of the object. So, we have two scenarios. So, one looks like this. Here's the water. The object looks something like this. We have 1/5 here. So let's say V over 5. So V is the volume, which is what we want. And here we have 4/5 V. And here, the forces that are acting are gravity, which will be, I'll say, rho Vg. And then we have the buoyant force. So that's, I'll say, Fg. And the buoyant force, Fb. And then, in the new scenario, the entire block becomes submerged, and we have a force, which I'll call F, being 3 newtons. We have a new force upward, which is Fb prime, the new buoyant force, and we once again have the same force of gravity, Fg is rho Vg. So, and here now the entire volume is underwater. So here, from this equation, we can see that rho Vg, which is the force of gravity, has to equal the buoyant force, which is 4/5 V times rho of water, so I'll say rho W, and then times G. And so from this, we can see that rho is 4/5 rho of water. And now on the right side, we can see that the downward forces, F plus Fg, which is rho Vg, equals the buoyant force, but now the entire volume is displacing water, so we have rho water times Vg, and so now we have V times rho water minus rho times G equals F, and so V equals F over rho G times rho water minus rho. But if you see, rho is 4/5 rho water, so we could have written rho water is 5/4 rho. Or excuse me, let me keep it as in this form. So here we get 1/5 rho water, and so we have 5F over G rho water. And so thus, we see that all in SI units, the force is 3 newtons, G is 10, and rho is 1,000 kilograms per cubic meter. And so we have 1.5 times 10 to the minus 3 cubic meters. But remember that 1,000 liters is 1 cubic meter, so we have 1.5 liters. And so we can go back here. We can see that that is the answer. Alternatively, if you wanted to do it in a slightly simpler way, what you could have seen is that just the force of 3 newtons just has to equal the extra buoyant force, which equaled 1/5 of the volume, or excuse me, that since the density of the object is 4/5 the density of water, then the, that the gravitational force is only 4/5 of the total buoyant force, meaning that the 3 Newton force basically just has to provide that extra 1/5 of the buoyant force, from which you could then calculate fairly easily that the buoyant force, the total buoyant force has to be 15 newtons, from which you can then see that the volume of the object is 1.5 liters. So that's another way of doing this problem. All right. Thank you for watching, and I hope that was helpful.